felt, completely tiny? Well, we're about to find out exactly how small we really are. We're going to go on a journey to really wrap our heads around the scale of the universe, starting right here at home and zooming out one giant leap at a time, all the way to the edge of everything we know. Trust me, it's a trip that's going to stretch your imagination. So, before we blast off, let's just ground ourselves with this idea for a second. Everything, and I mean everything, that has ever mattered to us humans, every person we've loved, every song we've sung, every battle fought, it all happened right here, on this one little planet. Just keep that thought in your back pocket as we start to pull away. All right, first up, our cosmic starting point. Every epic journey needs a starting line, right? And ours is right here on planet Earth. This is home base. This is our frame of reference as we start to measure the mind-boggling distances that separate us from, well, everything else. Okay, next section, measuring our backyard. So to really get a feel for cosmic scales, you got to start local. I mean, before we can even begin to talk about the space between stars, we need to get a handle on our own little neighborhood, our own cosmic backyard. So let's start with our closest neighbor. Our first stop is our constant companion in the sky, the moon. It's sitting up there about 384,000 kilometers away. Now, that number sounds big, sure, but what does it actually mean? Let's try and put that into a perspective that we can actually feel. Picture this. You hop in your car, you point it straight up, and you just start driving. Even if you kept a steady highway speed, no stops for gas or snacks, it would take you 160 days to get to the moon. That is a 5-month road trip. And remember, this is literally the smallest first step on our journey. Okay, so you think that was far? Let's take a much, much bigger leap. The distance from us to the center of our solar system, the sun, is a cool 150 million kilometers. This distance is so important, so fundamental to everything, that astronomers actually gave it its own special name. And that brings us to the astronomical unit, or AU for short. You can think of it as our brand new cosmic measuring tape for getting around the solar system. So 1 AU is just that distance from the Earth to the sun. It makes the numbers a little less crazy, but don't let that fool you. The scale is still just immense. Just to put that one little AU into perspective, if you could somehow get on a regular old commercial jet and fly it straight to the sun, that trip would take you about 19 years. 19! So next time you're on a 6-hour flight, just think, it could be worse, right? All right, section 3, beyond our sun's reach. So now that we've kind of measured our local neighborhood, it's time to push the boundaries. We're leaving the planets in the rearview mirror and heading out to the very edge of the solar system, getting ready to dip our toes into the vast, dark ocean between the stars. Meet humanity's most distant ambassador. This is the Voyager 1 probe. It was launched way back in 1977, and it's been traveling ever since, for more than 4 decades. Right now, it's over 22 billion kilometers away from us, a silent little explorer that has actually crossed over into interstellar space. And this little probe gave us one of the most powerful images ever taken. So back in 1990, the great astronomer Carl Sagan had an idea. He asked NASA to turn Voyager's camera around one last time and take a picture of home. And from 6 billion kilometers away, this is what it saw. Earth. A single tiny pixel. A pale dot. As Sagan so perfectly put it, it shows our entire world as just a small speck in the immense universe. It really makes you think, doesn't it? As we venture out of the solar system, even our new measuring tape, the astronomical unit, it just becomes too small and clumsy to work with. We need a bigger one, a much bigger one. So say hello to the light year. Now this isn't a measure of time, it's a measure of distance. It's how far a beam of light, the fastest thing there is, can travel in 1 year. And that is a mind-melting 9.5 trillion kilometers. So, using our new light year ruler, the distance to the very next star system over, Alpha Centauri, is 4.4 light years. See? The number itself seems small and manageable, 4.4. But let's unpack what that really means for a journey. And this is where the scale of space just becomes almost impossible to comprehend. Even our fastest, most distant probe, Voyager 1, would take over 70,000 years to get to our nearest stellar neighbor. 70,000 years. The emptiness between stars is just staggering. Okay, so section 4, islands of starlight. We figured out that stars are incredibly far apart from each other, But they're not just scattered randomly through space. Nope. Gravity pulls them together into these enormous, breathtaking structures, vast islands of starlight that we call galaxies. Our home, the Milky Way galaxy, is this gigantic spiral disk made up of hundreds of billions of stars. Just to fly from one side of it to the other, even at the speed of light, would take 100,000 years. Our entire solar system, everything we've talked about so far, is just a microscopic dot inside the structure. Now think about this for a second. Ever since we started broadcasting radio and TV signals, they've been spreading out from Earth at the speed of light, creating this sort of human radio bubble. But that bubble is only about 100 light years across. That means for 99.9% of the stars in our own galaxy, we are completely silent. They have absolutely no idea we're here. You know how you have a street address? Well, our galaxy is part of a small galactic neighborhood called the Local Group. That neighborhood is part of a bigger city of galaxies called the Virgo Supercluster, and all of that is just one tiny corner of an even bigger structure, the Laniakea Supercluster. Laniakea, which is a Hawaiian name that means immense heaven, is, well, it's immense. It's home to over 100,000 galaxies, including ours, all drifting together through space. And it stretches over 500 million light years from one end to the other. Our whole galaxy is just a single grain of sand on this massive cosmic beach. Okay, final section, the limit of sight. We've gone from our planet to our star, to our galaxy, to our supercluster. Now for the final leap. We're pushing out to the absolute edge of everything we can see, the boundary of the observable universe. And this is where we run into a really fascinating puzzle. We're pretty sure the universe kicked off with the Big Bang about 13.8 billion years ago. So you think, logically, that the farthest we could possibly see would be 13.8 billion light years away, right? But the observable universe is actually about 93 billion light years across. How is that even possible? The answer is one of those things that just completely bends your brain. It's not just that things are moving through space, it's that space itself is expanding. The best way to think about it is like dots on a balloon. As you blow up the balloon, the dots get farther apart, not because they're walking around on the rubber, but because the rubber itself is stretching. The very fabric of the cosmos has been stretching since day one, and that's where all that extra distance comes from. And this all leaves us with the ultimate question. The observable universe is just the part of space whose light has had enough time to reach us. So beyond that horizon, there is almost certainly more universe, more galaxies, more stars, more everything. But because space is expanding faster and faster, we will never ever see it. Its light will never reach us. We're living in this tiny little bubble of what we can see, inside a possibly infinite cosmos that's forever beyond our reach. So what do you think is out there?